Subtraction is much more complicated than addition in church numerals, and frankly, it's not worth the time to go into all of the detail of all of the steps, because the whole point of lambda calculus is abstraction, and you should be able to understand abstractly why this works without having to actually work through every single step. I'm going to talk about predecessor instead of the actual subtraction function, because subtraction is just implemented as repeated predecessor, and the way to repeat something is use a church numeral. All a church numeral is lambda f dot lambda x dot do f the number of times that this number represents. So if you want to do predecessor twice, well, lambda f dot lambda x dot ffx, make predecessor be that f, and 2 be that x, and now you have 2 minus 2. So we'll just look at predecessor here. Predecessor is a very complicated function, so let's just break it down into its constituent parts. Indeed, it's going to take a number as input, so it's going to do some function n many times over some input. What is that function? Well, the lambda p here is going to generate a pair of successor to whatever the head of the previous pair was with the head of the previous pair. And we start at the pair 0 and 0. So what we're saying is the initial value is just the pair 0 and 0. The first application of the function is going to take that pair, take only the first part out, make the successor to that, and then pair it with itself. So our first was the pair 0 and 0, then after one application of the function, we end up with the pair 1 and 0, because the successor to 0 is 1. If we apply this function again, we're going to pull out the head of that previous one, which was 1, 0, and then take the successor of that and pair it with itself. So now we get 2, 1. The next application of this, we get 3, 2, then 4, 3, 5, 4, as many times as you choose to apply this function. And how many times do we choose to apply this function? As I've said several times by now, all that a church numeral is do this function this many times. So we're going to take the church numeral and let that decide how many times we do this function. So if the church numeral is 3, we will apply this function 3 times and end up with the pair 3, 2. Now this is our ultimate result. We end up with the pair 3, 2 if we did it with 3. Then we get the tail of that, which is 2. The predecessor of 3 is 2. In this case, we gave the predecessor of 2, so we'll apply this 2 times. The final result will be the pair 2, 1. Then we take the tail of that, which is just 1. And indeed, the predecessor of 2 is 1. And 1 is lambda f dot lambda x dot fx. Now, I said I didn't want to show subtraction, just predecessor, because subtraction is just repeated predecessor. And, well, here's the reason. This example is 2 minus 2, and you can see just how wide it scrolls, because it gets pretty big on the way to doing even something as simple as 2 minus 2. But again, you should understand it abstractly. This is just repeating predecessor 2 times. And after all of these steps, we indeed get to lambda f dot lambda x dot x, which is apply f 0 times. You can see all of these steps using this tool, which is available on the course webpage.